So last time we followed DNS across the internet. We watched it search through DNS servers and eventually discover Google's IP address. Let me show you quickly how can we find the IP address of any website. So in the terminal we did nslookup google.com, and this will give you the IP address from where we can access the site directly instead of using the name. So if I copy this and then paste it directly in the browser, you would see that I would be able to access Google page, right? And it's loading up with just a use of IP address. And even if we have an IP address, this doesn't mean that the page would load up because still few steps are involved. And I will see what are the next steps after getting the IP address which are involved to access any website. So the answer is hiding in the next few milliseconds, and those milliseconds are doing far more work than most people realize. So at this point, DNS has completed its job. Your browser now knows exactly where Google servers live. Think of DNS as Google Maps. Its job is simply to find the destination, but finding the destination and starting a conversation are two very different things. Knowing someone's address doesn't mean they are ready to talk. So let's start this by a simple house analogy. So imagine a friend which gives you their home address. Can you immediately start a conversation? Of course not. First, you would need to travel there, then you would knock, then somebody answers, and only then can the conversation begin. Internet follows the exact same rule. Before any web page can be downloaded, your browser must first introduce itself. So right now you know where Google lives. To Google you don't exist yet. Before any data can move from the Google server to your browser, both sides need to agree to communicate, and this is where TCP enters the story. And for the communication to happen, your browser sends a small message called SYN, and don't worry about the name. Think of it as a knock on the door. Browser is simply asking, "Hi Google, are you there?" And that's it. No web page request, no search result, just a digital knock. Then the Google receives the message. Then it replies, "Yes, I'm here and I'm ready to acknowledge your request." So the response is called SYN-ACK. That means the destination website you are trying to access has acknowledged your request and giving a response back. Now next, your browser responds one final time. That is, your browser now acknowledges that request that Google is accepting, and at that moment something important happens. Connection is established, a door is officially open, and your browser and Google are now ready to communicate. And this is what it's called TCP three-way handshake. And here is the part that surprises most people. Even after all of that, Google still hasn't sent a website. There is no logo, no search bar, images, or no buttons, nothing. All we have done so far is open the door. Conversation hasn't even started yet. So before the real conversation begins, another major component joins the story, that is HTTPS. So imagine discussing something private, like putting up your password and username or any personal information in any website. You wouldn't want strangers listening, and HTTPS creates an encrypted channel between your browser and the Google or any website. And now the conversation becomes secure, and only the two participants from your browser to the website can understand the information what's being exchanged. So now the browser finally sends its first rail request, and in simple terms it says, "Please send me your homepage." And this is the moment we have been waiting for. Browser is finally asking for the website, and Google doesn't send a finished web page. Instead it sends pieces of information like HTML, CSS, JavaScript, images and fonts, everything required to build the experience you see on screen. And now your browser gets back to work. All these pieces of information comes together and finally we see the website. And all of this happens in the milliseconds. That is, DNS found the destination and the TCP established a connection. Then we have is HTTPS, which is securing your conversation, and the browser is sending the pieces of information that is required to load the website, and all in just a fraction of a second. Now let's recap. For a website to access, for example google.com, our browser will do a DNS lookup to find the destination IP address, and then the TCP handshake will happen in these three steps. Then we have is HTTPS for security, and then we'll finally see the browser. And every website you visit follows a journey like this, whether it's Google, YouTube, Microsoft, or your favorite online store. This hidden process happens every single time you open a website. And even though now everything is set up, one mystery still remains. If hackers can see traffic moving across the internet, why can't they read your passwords? And how does HTTPS actually protect your data? So that's exactly what we'll uncover in the next video. Give a like and subscribe if you like the video, and I'll see you in the next one.